It looks good to me.
Excellent, thank you.
Thank you.
So without further ado, we'll go ahead and get started with our current climate and drought outlook. Before I begin, just a few general information announcements that this is a collaboration that we do in the central region or north central US between the state climatologists, NOAA, the National Weather Service, USDA, climate hubs, the Midwest and High Plains regional climate centers, and the National Drought Mitigation Center. Our next webinar will be on March 18th, and Pat Gannon, who is the state climatologist of Missouri, will be presenting the climate and drought outlook then. And you can view the past webinars on a couple of those sites there that are linked. On today's agenda, we're first going to be going briefly over what happened in January in terms of temperature and precipitation rank. We'll talk about this recent extreme cold we've seen this February, go over some conditions like snowpack, ice cover, and soils. Then we'll shift over into impacts that we've seen, particularly from this recent cold event that we've had, and then we'll go into the outlook. Just want to point out that I took some of those snowflake pictures early last week. The snow that we've been seeing has not been a very wet, heavy snow. We've had very light and fluffy snow with opportunities to take pictures of some beautiful flakes all throughout the region. Here are the ranks for January. This is released by NCEI at NOAA, National Centers for Environmental Information at NOAA. On the upper left, you can see the statewide average temperature ranks for January, and this is out of 127 years of record. So anywhere that you have those red shading are warmer than average temperatures. And the number gives the rank out of that 127 years. So as you can see, the North Dakota, South Dakota, and Montana and Minnesota ranked very high in the top 10 warmest Januaries on record. Also notable was Michigan, but overall, all the region and most of the United States really saw a warm January. For the entire US, this ranks as the 9th warmest January in that 127-year record. On the lower right, you'll see the statewide precipitation ranks for January. Anywhere where you have those brown shading is a drier than average month, and the bluish greenish shading is a wetter than average month. So we've had a little bit of a mixed bag throughout the US and throughout the north central US, which we're focusing on, particularly Colorado, Wyoming, Montana, North Dakota, dry, and then shifting over into wet, more in the central US, and then a little bit dry in Wisconsin and Michigan there. But overall, not anything too extreme for January. So for the majority of the cold season, we have been seeing these warmer than average temperatures. This is looking at the departure from normal temperature since the beginning of November and then through the end of January. And this even continued, I'd say, through about the first week of February or so. These temperature departures that we're seeing throughout the north central US are anywhere from 2 degrees above average to those red colors being 6 to 8 degrees above average, really showing up there in the Dakotas and Minnesota and Montana. And this has had an impact on these areas being able to keep any sort of snowpack with those warm anomalies. And for a lot of the north central US, we've also been experiencing drier than average conditions. This is extended from a lot of drought conditions in the warm season in 2020. And a lot of the region has continued to see drier than average conditions. This is since October 1st through February 16th. And where you see those orange colors, you're looking at about a 1.5 to 3 inch deficit of precipitation for that time period. Now, this isn't a particularly wet time period. So climatologically speaking, we wouldn't expect to see a lot of precipitation, but it doesn't help in the situations where areas have already been dry. So we broke from that warm, dry pattern that we've been in, and over the past week or so, we've started experiencing this major cold event that has swept across the entire country, and we've seen a lot of cold extremes throughout our entire north central region here. So the map on the left shows the departure from average temperatures just for February 12th through February 16th, which is really when the maximum power of this cold event was impacting our region. And you can see there all throughout the entire center of the country, cold anomalies where temperatures were 20 degrees or more colder than average. And this extended to the east and west with colder than average. There were only a couple of isolated locations in the country that weren't impacted by this. This is a zoom in a little bit, and not only are we zooming into the region, but we're also just looking at the maximum temperatures, so those daytime high temperatures, because that's really where we saw some of the biggest extremes. That purple shading that you are seeing is showing where temperatures, high temperatures, were 40 degrees or more below their average temperature. So this was really quite the cold event. We're going to focus in on just one interesting station here. This is from Wichita, Kansas. And what we're looking at is a daily temperature graph since the beginning of January. The brown shading shows the range between the average high and the average low for those days. And then the red shading at the top goes up to record daily highs, and the blue shading at bottom goes to record daily lows. And then each of the blue bars is the daily temperature range observed in 2021. So when it goes into that red shading, it was an above average temperature for the day. And when it goes into the blue shading, it was a below average low temperature for the day. So for most of January and into February, you can see temperatures fluctuating between warmer than average days and near average days, a little bit of a colder event in late January, but back to those warmer average days. And then as you get into mid-February, it just plummets. And so looking at that February 7th through February 16th, all those days, excuse me, let me take a drink. All those days are well below average, and you can see on the latest 3 days, they actually had those daily lows turn into record daily lows. So quite notable to see on the graphs there. So was this cold record breaking for a lot of areas? What I did was I took a lot of our long-term stations that have normals recorded. Most of these stations have 30 years or longer of record. And I wanted to see if any of them had broken their records for coldest February temperature. So some of these are going to be a little bit shorter term, 25 to 30 years, but a lot of them are going to be some of those longer term stations. But you can see anywhere where there's a dot, that station broke a record for their coldest February temperature, and it's color coded based on what that temperature is. So you can see that we've been hearing a lot about what's been happening in Texas. A lot of new February cold temperatures in Texas, but a lot of those are still above zero. And near zero when you get into those green colors. As we get up into our region of interest, looking through Kansas, eastern Colorado, Missouri, and then to the north, these values were solidly below 20 degrees below zero. And those light blues that you see in Montana, North Dakota, Minnesota are areas that got below negative 40 degrees Fahrenheit. Actually, negative 40 is the same Fahrenheit or Celsius. So quite the cold event there with those records. And then when we look at the maximum temperature records, we also see that there were quite a few stations throughout the United States that got their coldest maximum temperature for February ever recorded at those stations. And in the yellow down south, those records are still above 20 degrees. But a lot of the purples you see in the north central plains and going up into that lighter purple pinkish color, we're looking at high temperatures that were below zero, and in some cases 10 to 20 below zero. One thing that I do want to remind us is that just because we've had a lot of cold records doesn't mean that climate change is not happening. But this is something that you can look at on the NCEI and NOAA website at the link at the bottom. They have a table that they update daily with the number of records that have been broken. And so we always have warm records and cold records being broken. Over the last 365 days, you can see that the warm record numbers quite outpace the cold record numbers for the US. But in the last 7 days, those cold record numbers have been definitely taking the lead over the warm record numbers. While this cold was quite exciting and memorable, it didn't bring a whole lot of snow with it or precipitation. So on the left, we see the accumulated precipitation since the beginning of February for the region. Those oranges, yellows, those areas have gotten less than 1/4 of an inch of moisture since the beginning of the month. Some isolated spots further to the west have gotten 1/2 inch to 1 inch. And then as you move closer to the Mississippi Valley, then you get into areas that have gotten more than 1 inch of moisture in since the beginning of the month. On the right there, you can see what those departures are compared to average month to date. So again, we don't expect to see a whole lot of precipitation this time of year, so the deficits aren't too big, and the anomalies, above average anomalies, are not too big either. This is the accumulated snowfall the region has seen since the beginning of October. Those green colors that we see are areas basically starting from 10 inches of seasonal snowfall up to widespread 30 to 40 inches of seasonal snowfall. Interesting to note that Lincoln, Nebraska has gotten a lot more snowfall than where I live in Fort Collins, Colorado, which is not something that you would typically think, but there it is. But on the right-hand side, I wanted to show a graphic of snowfall anomalies, but those anomalies are so big, plus or minus 20 inches, it's hard to get a sense of it. But overall, we're seeing that where you see those darker green swaths on the map on the left, they have gotten above average snowfall for the season. Eastern Colorado is a bit closer to average, and it has been a bit low for the Dakotas. This is a look at snowpack. Snowpack is a little bit different than snow depth or snowfall in that it tells you total how much water is in the snow that is on the ground right now. So in the grays, we're seeing a trace, meaning not really measurable, to just 1 inch of snowpack. So there's not a lot of moisture on the ground from the snow right now, where you see that gray shading across a lot of the lower elevations. The exception is where you start to get into that light blue, which you've got 2 to 4 inches of liquid water in that snow in eastern Nebraska, and then extending through Minnesota, Iowa, Wisconsin, northern Illinois. and into Michigan. I have delineated the boundaries of the major watershed basins in black. And so the Missouri Basin, you can see that black line goes through the middle of Kansas and into Colorado. Then it goes up across diagonally across Wyoming and into Montana. Anywhere east of that line is snowpack that is going to impact the Missouri Basin. So those purple colors that you're seeing in Montana and northwest Wyoming, those are going to be snowpack that will eventually melt into the system for the Missouri River Basin. But anything west of that black line is not going to really impact our basin. These are basin percent of average snowpack. This is from the NRCS. And this just shows kind of where the snowpack stands for a lot of these basins through Montana, Wyoming, and Colorado. And so those orangish colors mean that the basin snowpack is a little bit less than average. Thankfully, we're not seeing that dark orange and red. These are graphs that specifically show the snowpack accumulating over time for some of these basins. This is for the Platte River Basin with the North Platte on the left side and the South Platte on the right side. The red line is what is typical for taking a long-term average of snowpack throughout the season. We typically expect to see snowpack building rapidly right now towards a peak, which would happen somewhere in mid-April. So on the both of them, we are seeing that snowpack as a little bit below that average line when we're tracking along with the blue shading. According to the graphic, the North Platte is 87% of average and the South Platte is 79% of average. We still have a bit of time to make up those deficits, but it is also pretty hard to make up those deficits by this time of the year. So this is a similar graphic for the Missouri River Basin. On the left is above Fort Peck, and then the right is the total for Fort Peck to Garrison. This has a little bit of added information on it. It shows some analog years that you can compare to with 1997, 2001, and 2011. But what you really want to see is that similar to the last one, the blue shading shows that we are just a little bit below the average of where we want to be with total snowpack for this time of year. And so it's going to be pretty hard to make up those deficits. And it is becoming increasingly likely that the areas where the snowpack is less than average right now is more likely to end up with a peak that is also less than average. Add to that soil moisture is just not really great across the region. So this is looking at modeled soil moisture from the Climate Prediction Center, and anywhere where you have those oranges and reds are where the soils are quite a bit drier than average. And in areas where the soils are really cold and frozen, if they don't have much moisture, they might not be frozen with moisture. But for the mountainous areas that started the cold season with those soils that are drier, that's going to be an issue when the snowpack starts to melt as well, because there will be less available for water supply and runoff. But throughout the region, eastern Colorado into Kansas, Nebraska, the Dakotas, and Iowa, we're seeing a lot of those really dry soils. A little bit wetter soils as we look in the southern parts of Kansas, Missouri, and Illinois. And then again, as we get up into northern Indiana, Michigan, some areas of drier soils there. As of this time last month, we didn't have much in the way of frost depth, and the soil temperatures were still a bit warmer. But because of this cold, we have definitely seen widespread increases in the frost depth across the Midwest, which you can see with the map on the right side showing what those frost depths are. On the left side, we're seeing soil temperatures. That's that 4-inch soil temperature under sod. And those have all widespread cooled since our last presentation. And there's much more significant coverage of frozen soils, which is anything in that purple color. That dark purple to the pink colors would be those frozen soils. And this is going to lead to precipitation events that occur after this, especially liquid precipitation events are just going to be more likely to result in runoff and not infiltrate the soils. For areas that could have wetter soils in the probably in the lower Midwest, risk of flooding could be a concern in the Ohio River Valley. And then areas that have been drier to the west, there is going to be less potential for soil recharge if that soil is too frozen for that any precipitation to infiltrate in. Quick look at the 28-day average stream flow from the USGS. Every dot is a stream gauge, and it compares the stream flow for this 28-day period to the historic 28-day periods. So greens, blues, and blacks are above normal flows for this time, and then oranges and reds are below normal flows. We see areas of below normal flows throughout Colorado, which is a holdover from drought last year. We see areas of northern Indiana, Ohio showing drier, lower stream flows, and then areas throughout Missouri and Illinois down into Kentucky are showing a little bit above average stream flows. If you look in the northern area of the North Central Plains, you see there's not a lot of gauges that are reporting, and that is due to a lot of them being affected by ice. They tend to stop reporting when they become ice affected. Here is a look at the ice cover over the Great Lakes, and I have an animation to show how it's changed over time. So this is early February. If it's color shaded, it is water temperature. And then once it goes into that black and gray shading, that turns into ice cover. So when we were at the beginning, I want to start that over again. When we were at the beginning of February, we had total ice cover on the Great Lakes at 10.7%. Most of the Great Lakes you can see were not covered in ice. And then as we advanced through this month, just to the middle of the month, that ice cover has increased to almost to over 40%. And that's particularly been the case for Lake Superior being so far north, and Lake Erie, which is more shallow and easier to freeze in these cold temperatures like this. So we've seen a quick increase in the ice cover over the Great Lakes. Final for the current conditions is a look at the U.S. Drought Monitor just released this morning. And this is looking over the north central U.S. You can see on the left side, we've got Montana, Wyoming, Colorado. Sorry about that, sensitive mouse. And then extending east through to the Ohio River Valley. On the west side, we have quite a bit of drought especially in Colorado, where we have significant areas of the D3 and D4 drought, which are the worst drought categories. As we go north and east, we get into those D2 and D1 categories, which are your moderate drought and severe drought categories. Then we go into the yellow, covering a significant portion of Minnesota and northern Wisconsin. D0 is not a drought category, it is an abnormally dry category. And then where there's no collaring, we don't have drought conditions depicted right now. Let's talk about some of the impacts. Some of the cold stats that I received for this webinar, that Des Moines, Iowa spent 66 hours below zero, and that ranks in their top 5 for the number of hours spent. In the Twin Cities in Minnesota, they're 3rd place all time for their total number of hours that are at or below zero. They did have a streak of 116 consecutive hours below zero, which sounds miserable, but apparently that doesn't even crack the top 10 for their consecutive hours. It was pointed out to me that currently Austin, Texas has more snow on the ground than Aberdeen, South Dakota, which is quite notable. On February 16th, Lincoln, Nebraska dropped to 31 degrees below zero, and that comes in 2nd place for their all-time coldest temperature. Also, Chicago broke the record for consecutive days of measurable snowfall, 9 days in a row that they had measurable snowfall. And then the graphic here, what the table shows the number of consecutive hours at or below zero throughout South Dakota at their Mesonet sites. So some of these stations you see here that top the list, 279 consecutive hours of below zero. And then the lowest one on their list was Dakota Lakes at almost 64 consecutive hours. There have been a lot of urban impacts that are of note from the snow and ice and cold. There have been many rolling blackouts, not making the news quite as much as Texas, but this cold has been quite extreme, and so rolling blackouts have been reported in Nebraska, Iowa, and Kansas. There have also been some water main breaks, particularly in southern Illinois and Indiana. Tens of thousands in Kentucky have been reported without power and trees down from the ice storms that they've had there. There's obviously been concern with sheltering homeless individuals, and Chicago shelters have been at capacity due to this event. They've also had buildings that have collapsed underneath the snow. You can see a picture of one of those in the lower right-hand corner with that news article. And then early in February, there was a large pileup on I-80 in Iowa that included about 40 vehicles, and you can see that from a traffic cam on the lower left there. There's also quite a few hydrologic impacts to talk about. The Army Corps has been increasing releases to help alleviate these ice conditions. There was an ice jam yesterday near Jefferson City, Missouri. There have been some ice jams reported on the Platte River in Nebraska, but that is pretty typical for this time of year. Further north, it doesn't seem like there's a concern with ice jams quite yet because it's still too cold, but that's something they're watching for. And that's when we really want to start talking about the potential future impacts from this. We're in this waiting game right now, but if we have a fast warm up, we're definitely going to have more problematic ice jams throughout the region. Also, if we have a rain event, that would increase ice breakup and the potential for jams. And then we're also looking for a possible risk of flooding in the Ohio River Basin. To the west, our risk and impacts, we're talking about mountain avalanches. The picture on the left shows the avalanche forecast for Colorado. So you can see in the map where the Front Range urban corridor is, Fort Collins, Boulder, Denver, Colorado Springs. Everywhere west of there, pretty much all of the high elevations are in this considerable risk for avalanches occurring. A couple of interesting news articles that I came across. One that talked about the Utah mountains seeing an unprecedented level of avalanche danger. And in that article, the Colorado Avalanche Information Center was quoted as saying that so far in this winter season, 25 people have died in avalanches. And we're on track for having one of our highest avalanche deaths seasons in a long time. I think the record high was 36 people in a season. So unfortunately, we are on track for that. We just had a death on the 16th that wasn't quite reported in Colorado from a snowmobiler. And then another headline is about this elementary school principal from Montana who died in an avalanche on Valentine's Day. And the Nikki Champion from the Utah Avalanche Forecast Center basically says that this avalanche season is very active, likely because of this persistent weak layer of snow. And every time we're adding a lot of new snow on that, it's even further weakening that weak layer at the start of it. And in snowpack with avalanches, you're only as strong as your weakest link. There are potential agricultural impacts from the cold, even though they might not yet be realized. Thankfully, this deep cold was well forecast. So when we're talking livestock and they're early in their calving season, we've only heard of minor impacts, moving livestock inside to keep them sheltered from the extreme cold, but no major impacts reported at this time. In Iowa, fruit trees have been impacted by the cold. Apparently 18 below zero is killing for peach blossoms. And so this extreme cold means they're not expecting a good peach crop this year. On the other hand, fruit trees in Michigan have now officially reached their chilling requirements. So once the temperature warms, they're able to break dormancy. And then the next thing that we're really watching is winter wheat, which is still dormant. In the West, the problem will be that this extreme cold has combined with very little snow cover, and that snow cover helps insulate. So when you don't have it, they're much more exposed to that extreme cold. And so it's likely that winter wheat is going to see widespread damage from the cold, but we won't know the extent of that until the spring. Continuing on to impacts that we'll see from drought, in the agriculture, widespread throughout our region are reports that there is lack of deep moisture in the profiles of the soils, largely from the drought in 2020. And this is something that's going to carry over and impact the region once we start thawing out and entering the spring. So we also expect that there could be winter wheat damage from these drought conditions. At this time, it's going to be difficult to separate the damage to winter wheat that's happened from the cold versus damage from the drought, but you can expect damage from both. And we're also expecting that there's going to be lack of adequate pasture and forage in these drought-stricken areas for livestock. With all this cold, it's hard to remember, but fire is also still a concern at this time. Early in February, extended dry conditions and high winds increased fire danger in parts of Colorado and Kansas. There was a brush fire near Denver metro area on Super Bowl Sunday, and it resulted in an evacuation of neighborhoods nearby. It was quite worrisome because it brings up that we know we're in drought and we know that more fires will come. So we have this drought in the West, and we're also coming up to the windy season on the high plains, where we see a lot of windy days throughout March, April, and even into May. So we can expect to see lots of red flag warnings and high fire danger on those high plains. So that's something to keep an eye out for. Going to shift over to an outlook now. This is the 7-day precipitation forecast map over the lower 48 states. The greens show where we expect to see some precipitation in the next week. Unfortunately, where there's white, we're looking at a dry week. Light green is not incredibly helpful. We get those darker greens as we move more into the Midwest and Ohio River Valley, where they expect to see anywhere from 1/4 to 1/2 inch over the next week. And then the mountain areas on the west side, we can expect to see 1 inch or more of moisture, which is pretty typical for mountain regions this time of year. Should be getting at least 1 inch of moisture or more every week. Expect these colder temperatures to last through the end of the week. And then we can see a transition to a little bit warmer or more seasonal temperatures early into next week. 8 to 14-day outlook from the Climate Prediction Center focuses on February 25th through March 3rd. And instead of an actual forecast, it shows the likelihood of above average or below average conditions. So on the left is for temperature. And through most of the north central US, we would expect to see an increased chance of above average temperatures. The western portion of our region, though, more likely to be near normal, so pretty seasonal. On the right is looking at precipitation likelihood for that 8 to 14-day time period. In that light green, slight leaning towards wetter than average conditions with a little bullseye over southern Illinois, Indiana, Ohio, Kentucky, and then move west from there, and there's a slight leaning towards drier than average. But I would say with that light green and light brown, mostly it's going to be near average, which is not really a lot of moisture for this time of year. So we are currently in a La Niña, and we can expect that to continue through the spring. On the left-hand side is a graph that shows the probability of La Niña in a blue bar, El Nino in a red bar, or neutral conditions is a gray bar. So for that January, February, March time period, obviously we're in that La Niña. And then we can see that that blue bar decreases a little bit through the spring. The March, April, May time period shows that we still have a greater than 60% chance remaining in the La Niña conditions. And then as we transition from spring into summer, neutral conditions become more likely. So in the May, June, July time period, there's a 60% chance that we will be out of the La Niña and into neutral conditions. And then what happens late in the summer and early into the fall is a little bit more of a crapshoot, so I wouldn't place any bets on that at this time. On the right shows what all the various models are predicting for those sea surface temperature anomalies that dictate whether you're in an El Nino or La Nina. So when you're at that -1, which shows up on the graph in that December, January, February time period, that is a La Nina sea surface temperature anomaly. Getting closer to the 0 is that neutral. And then you'd be in an El Nino if you got above a 1/2 degree above average anomaly. So the models are all over the place in the late summer, but showing that we are gradually coming out of this La Nina, but we'll still be in a moderate to weak La Nina as we go through the spring. And the reason this is important is because we're going to really see that La Nina signature when we look at the outlooks for March and for the spring outlook. So from the Climate Prediction Center just released today, here's the outlook for March. Most of the country is showing a leaning towards more likely to have warmer than average conditions, and then the exception being in the Pacific Northwest, where they are more likely to have cooler than average conditions. In the North Dakota, South Dakota, Minnesota area, equal chances means there's not a lot of signal. So there's not really any certainty whether it'll be above average, below average, or near average temperatures. On the right side is the precipitation probabilities for March. If areas that have been dry, unfortunately, have an enhanced chance of continuing to be drier than average into March. And then looking across the Great Lakes region and into the Ohio Valley, we are seeing an increased chance for wetter than average conditions. That combined with what's happening in the Northwest over Montana is a pretty good La Nina signal there. And what we see when we extend out and look at the March, April, May time period, so the spring outlook, very similar to what we just saw just for March, where we see most of the region showing increased chances of above average temperatures through the spring, especially to the south in southern Colorado and southern Kansas. Enhanced area of drier than average across the western part of our region, and enhanced area of above average precipitation over the Great Lakes region. And so what this means is those areas are more likely to see flooding with that having the higher stream flows, not as dry soils for some of those areas, and then increased precipitation, whereas we're going to continue to see more drought concerns where we already have drought concerns, because that is largely where a lot of the increased risk for dry continues. One more thing to note that I didn't have a graphic on is Great Lakes levels, which are still above average for all of the lakes, with the exception of Ontario, which is a little bit closer to average. So still have above average lake levels. Expect those lake levels to drop into March. That's typically the time that they are the lowest. And then we expect to see increases on all of them so that they continue to stay very likely in that above average lake level category. So that's all I've got. And I'm ready to take any questions that you may have.
Yep. Thank you, Becky. That was great. You covered too much stuff in way too little time. So as usual, that's what we do on these calls. But, you know, it's hard for us to go into great detail now. And someone just said you're a very gifted presenter, so I just want to pass it.
Oh,
I am
you very
going
much.
to, yep, I'm going to, golly, we have like 15, 20, 30 things. Some of these are comments, some of these are similar. So let me, some of these things we tried to address before we got into the question part, but they deserve a wee bit of attention on the call. So,
right.
And some of them actually we can't answer because we're not really the agency to deal with this. But you know, I'll just go over them anyway. Discuss the impact of cold crisis on electricity in the Great Plains and Texas. Very briefly, the reason I had a rolling blackout in my my house, and many of us did across this area, was or manyfold. And my understanding of this is that the energy was needed elsewhere or locally, both, and we had to pull energy from many other parts of the grid where they're used to having this kind of cold, i.e. the north. And it's just hard to transfer. It was just hard to transfer energy for a number of reasons. It's not as easy to do when it's cold outside. There were failures in various systems, and I'll just leave it at that. And how rare are these events? I'd say extremely rare, this event, but we seem to be saying that about a lot of events these days in terms of extremes, right? So easily, this will go down as another $1 billion+ event, easily, without a question. So that's kind of all we can say about it. I think there's quite a bit of study that needs to be done, and the impacts are still happening. So we're recognizing the fact that it's very odd, and Becky showed a bunch of good stuff there, indicating how odd it was. There's a lot of questions about why it happened, and so I guess we'll try and tackle some of that now. Questions like, and this is going to get a little technical for a few folks, was the Arctic oscillation and its influence part of the problem? Was the stratospheric warming that we had earlier, was this a result of that? Is the polar vortex involved, et cetera? So quickly and not very concisely, and really not going to give a great answer to this, but our ability to detect or forecast, I should say, these much more than 2 weeks in advance is not great. All right, it's just very, very difficult to do. We had this stratospheric warming event, which I won't go into detail, but what happened with that was, one, the cold air from that event went into Eurasia and Asia, and really got them very cold. Okay, part of the repercussion of that was the weakening of what we call the polar vortex, where the cold air loves to sit up there around the Arctic and spin around. Okay, well, when we weaken the winds or whatever, which that event did in late January and early February, it allowed the penetration of this cold air south. Okay, where, that's sort of, the model started saying North America, and, US and all that stuff. So we were able to pick up on that and start forecasting it. I'd say about 2 weeks in advance, that it would get cold. How cold that was, it's always up in question until maybe a week or so out. So, yes, and so the other thing I want to say about this, we call them teleconnections, or we'll just call them connections in the atmosphere. There's something called the Arctic oscillation that often drives a lot of cold air into the eastern part of the U.S. if it's in a negative phase. Now, I know that sounds crazy, but we had a whole bunch of negative phase, if you will, Arctic oscillation in January, and we were warmer than normal. So one does not necessarily lead directly to another, but often it does. That's one of the complicating factors with what we do in the climate world in terms of forecasting beyond a week or two. These are all really difficult things for us to handle, because of butterfly flapping, and you've heard this before, flapping in Australia can screw up our weather here, weeks or months later. So there's a lot of chaos.
Can I add anything to that?
Absolutely, please. You and Dennis.
Yeah, so one of the things that I wanted to bring up was a great analogy for me is a spinning top. And you can think of the polar jet that's going around the Arctic Circle as a spinning top. And when it's strong, it's got that tight spin, and this sudden stratospheric warming event or other things like that can kind of poke at it. And that little poke on that top starts to cause this wobble effect. And talking about that butterfly flaps its wings, when you start the top wobbling, you don't know exactly where those waves are going to wobble down to, but you know that they're going to come. And so when that polar jet is weaker, you're going to get more of that wobbly effect, and you're going to have these deep outbreaks of cold be a potential. And that's something that I've been emphasizing recently, because a lot of people are arguing that this proves that climate change doesn't exist, or there are people on the other end that say, well, this is because of climate change. And one for certain, I want to say, this does not prove at all that climate change does not exist. This is a part of the climate, and this is something that we can expect to continue to happen. But at this time, we can't attribute things like this to climate change. These These teleconnections, as Doug has put it, they're very complicated. It's hard to forecast out, and it's hard to completely understand the relationship with a warming climate and how these work out. So while this is unusual, I would say I don't know, we don't know that it's due to climate change, but as we can see that even in a warmer climate, we can expect things like this to still have the possibility of happening.
Right. And so what I would add to that is, for those of you who haven't experienced this in your lives, which could be actually a few of you, this kind of cold, feel lucky because it's rare and becoming more rare. So let me go back to Dennis. Dennis, what can you tell us about wheat in general and impacts? I know you've answered some questions here, but is there anything you can say in terms of impact to wheat from the cold temperatures?
Yes, I can actually update now. And in the time that it was asked, I reached out to my Kansas folks, our Kansas folks, not my Kansas folks, and their wheat specialist indicated that there is some concern of winter kill, more so in central to northwest Kansas, central due to more limited snow cover, and northwest because of more extreme cold. So again, it looks like there's going to be some quantifying that will take some time.
Okay. There was a lengthy question. It kind of goes back to the polar vortex and such, and La Niña overpowering the situation or anything like that. So my take on La Niña and the polar vortex and things of that nature are that La Niña doesn't really overpower. It may minimize or maximize, though, certain patterns like we just had. And are you going to ask me if this La Niña helped this happen? I can't answer that. Let's just say, though, it would be more likely in a La Niña year than a El Nino year. I think I could say that, or we could say that. Winter wheat. Okay, the wavier jet stream. Yeah, so this goes back to what Becky was talking about in terms of extreme events and having a wavier jet stream and having some connection to climate change and such. I'm not sure about this particular event, and the philosophy or the hypothesis behind that is not totally founded yet in terms of a wavier jet stream yet. We'll see over time and with more research in terms of extreme events. Okay, wheat. Wheat, dryness in the snowpack in the western states, and fires. So every year there's fires in the West, and every year it's because there's a lot of heat and a lot of dryness, especially June, July, and August and September and in October. That happens. There is a season. It's called fire season in the West. So there's a whole bunch of things that determine whether it's going to be a quote unquote good or bad fire season in the West. One of them is past growth, and when things dry out, and drought contributes to this, but is not the cause. But as things dry out after a good growth year, there's a lot more fuel around. So Becky, you might be able to say a little more about that in terms of how your drought in Colorado this last year may or may not have contributed to your major fires.
Yeah, we definitely in Colorado see a correlation between our bad drought years and the occurrence of large wildfires. Like you said, we have wildfires every year, but our really large ones tend to coincide with our years that we have bad droughts. And last year was definitely an example of that. So I would expect that areas with low snowpack, that we would continue to have a risk for large wildfires going into the next summer season. But there is that caveat that if we haven't had enough growth, that results in less fuel for fires. So I'm not sure how long that takes. Like if the fact that we had a wet 2019, but it was dry last year, could that mean, I think that there would still be enough fuel for there to be the potential for large wildfires this summer. And it's going to be a bigger risk if we have an early melt out of snowpack.
Yeah, right. That just extends the season, right?
Yeah.
So you're making a longer season of dryness. We had a question, how soon will these recordings and presentation be available? They will be available hopefully within 24 hours. It's sort of up to me getting it to the right people to put it online. So wish me luck. So hopefully by tomorrow, close of business. I'll just say it that way. And then La Nina reforming in the late summer months, fall. Yeah, the models are showing some indication that we may be in what some of us call a double dip La Nina, which aren't that unusual. So it wouldn't surprise us that we maybe lost the La Nina signal, the way we classify it, over a few months in the summer or late spring, and then it reforms or comes back again in the fall. No guarantees there. These trends appear to be becoming rather consistent, and I assume that means the extremes. What is the worst case scenario in both frequency and severity? Wow, worst case scenario? Well, go ahead, Dennis.
Gosh, thanks, Doug. Worst case scenario on what? There's so many worst case scenarios possible.
Yeah, I'm not sure. I think he's talking about trends in terms of. I'm just going to guess in terms of extreme events, and I you know, worst case scenarios, we continue our trend, which you just pointed out to us, and that we continue to have $billion+ increasing number of those, as well as increasing costs from those and impacts from those over time. That's probably the worst case scenario.
And it really points out what we need to do is to start focusing even more readily on resiliency, doing things that are more resilient.
Yep. And not to get into policy here, but a lot of that takes money, and so we have to think ahead, and that's about all I can say. So one more comment. Energy analyst. Just a comment about how well forecast this was. Relatively well forecast, and that perhaps infrastructure, not perhaps, but energy infrastructure was not prepared for this much cold for this long. And I think we can pretty much agree with that.
Doug, can I chime in on that real quick too?
Yeah.
That's the problem we have is this was reasonably well forecast in the way of pattern and timing, but there is a fairly finite difference between a fairly cold event that is not too problematic and the huge issue that this one has caused because of infrastructure issues, especially in the Southern Plains outside of our area. And it's hard to be able to make that jump to, well, it's going to be cold and there's going to be some problems, to this is going to be catastrophic. We're not very few people are going to say something like that. So, people are saying, why didn't we say it was coming? Well, we did. We just didn't know that it was going to be this bad and have the multiplying effects that we've seen in a number of places.
Okay, I'm going to get to a couple more things here. And is the Arctic oscillation related to the polar vortex? What I'll say about that is when you see a negative sign, when the Arctic oscillation goes negative, which, there is a website on the Climate Predictions Center's website you can go to, and to see a prediction out 14 days. And when it goes negative, it's more likely that the polar vortex will have some influence on the eastern 2/3 of the U.S. Usually not the west, mostly in the eastern U.S. It can bring if you will, polar and or Arctic air further south. There's, if you will, sort of a weakness developed. So there is a relationship. It is definitely not one-to-one. It just increases the probabilities. And our forecasting of the Arctic oscillation is limited to about 2 weeks. Dust, yes. So a lot of what Becky talked about in terms of drought in the plains will lead to, if we don't get precipitation, dust storms, or more likely dust storms on the plains this spring. No doubt about that. Any sign of drought across Wyoming and Colorado? So any signs of drought will end across Wyoming and Colorado. And I would say, based on what Becky has presented and some of the additional seasonal outlooks beyond March, April, May, do not look good for that. I'll just say it that way. So any signs?
Agreed.
Not a lot of signs.
I would say, adding my 2 cents, I would say dust storms are going to be very likely this spring across the high plains. And I would also bet that we're likely to continue this drought through the spring and into summer.
Yep. Okay, and thank you, Mary Baker, for your comments in terms of mitigation and the cold and people spending money on things in other places rather than shoring up for less likely events. Doesn't mean they shouldn't, just that was a decision that was made. Okay, on that note, I'm going to have to bug out because it's 2:05 and I've taken all of your everybody else's time. So I appreciate you all sticking with us. I also really appreciate Becky's time and effort. It's not small to put this on. Thank you very much, and thanks, Dennis, for adding your 2 cents from the USDA's angle. We will talk to you next month on the 18th at 1 p.m. Central Daylight Time. So have a good month, and goodbye.
Thanks.